Oh, hello, everyone. It's nice to see this so well attended. Anyway, you'll recognize me because I'll be on the phone like this. So, or if you see someone wearing a Julia jacket, it's just a jacket. Don't take it personally. Okay. So as a disclosure, my wife's a realtor. Am I in the mic? More or less. Okay, good. Okay, thank you. And we bought a house, we sold a house, we moved cross country. I went through all the agony. So I thought there must be some data that can be examined. So that's what this talk is about right here. Okay? So we can make this one go away if I can. Oops. Oh no. This is amazing. All right. Okay, so while we're talking about conferences, you should go to the conference in Florence. You can still submit a talk to it. And I'm still trying to figure out how to minimize this window. Here we go, thank you. All right, so I gave rather than doing a PowerPoint presentation, I thought I would do a poster session because I gave a version of this at JupyterCon back during the summer. And so I kind of stole that and reworking it. So we'll just go through this quickly. So the key things about real estate is that it's expensive, doesn't happen very often in your life, and everybody's trying to make money off of you, the person who's buying the house, because you're the one with money. So there are all sorts of things that get negotiated. The listing price, the selling price, the commissions of the agents. What you don't get to negotiate are things like taxes usually. Okay, so there are all sorts of different models for buying and selling, and I don't know what's common in Canada, but I'll assume it's reasonably similar to the States. And what I discovered while looking at some data is there seemed to be some clustering, a clustering that nobody else had really looked at in terms of how pricing happens. And the clustering, which I'm going to, is the effect of the realtor on the price, okay? So let's sort of build up to that. Redfin went into the market a few years ago. They've had an IPO. They're doing their thing. And their idea was that they could basically short circuit the realtor and give discount commissions. And well, their price has gone down since the IPO, so there's something they're still working out. Now you have another company, Zillow, and Zillow has this, can we see that? Does that 1.2 million show up? Here we go, yeah. They have a nice big prize. Oops. Here we go, 1.2. This is on Kaggle. If you don't know about Kaggle, you ought to take a look at it. It's a great place to try to make money while you're in between things. And Zillow is offering this prize money on Kaggle. It's a deep learning kind of thing. And here's their numbers. So they're getting 5% accuracy today. So 5% on 1.2 million is about, what, 60,000? So that's quite a range in terms of accuracy there. So that's why it's worth a lot of money to them to do that. All right, so one of the key things you hear about real estate is that it's all about location, location, location. Well, certainly location is useful in terms of drawing maps, okay? And one of the things we're going to look at is geographic proximity for this notion that I have of a farm. Okay, this is if you talk to your realtor friends, they'll say, oh yeah, I have a farm in this neighborhood, right? In this school, around this elementary school or something. You know, I just go and visit people, they know me, I deliver Christmas cookies, all that stuff. So 1 degree of latitude or longitude, depending on where you are, is about 111 kilometers. 1/10 of a degree is a large city, all the way down to this ridiculously small number that's good for tracking glaciers, okay? And if you have a differential GPS, you can get pretty close to that with some other cheats as well. Okay. So there are all sorts of tools out there, zillions of tools. And so I thought I'd kind of build my own tool just to get my hands on into it. And that is I'm going to like figure out where clusters might actually be. So I'm going to find all the transactions for a given realtor and see where they are geographically distributed. Some may be hither and yon, or some may be close together. So defining what close is a metric. And it's a nearest neighbor approach. But you don't want to, if you have this group here and this group here and this group here, you're going to say, well, that's really just one cluster. So you want to merge these. So it's an agglutinative process. So merging around, discarding buckets around, finding the convex hull. I grab something from SciPy to do that. Okay, and then I say, is it a farm by some characteristics? And then looking at comparing the listing price to the sales price. Is the price for a given realtor above or below? Right? Is there a trend between realtors? Now bear in mind that realtors may negotiate a listing price based on what they think the house will sell for, because if the house doesn't sell, they don't get a commission. So there might be a temptation to down price. On the other hand, that doesn't make clients happy, and reputation and ethics do play a fairly important role as well. So you might use that strategy, though, as a way of getting a bidding war going on. Because if you price the house above, say, the Zillow estimate, people say, oh, it's above the Zillow estimate, I'm not going to bid. But if it's below the Zillow estimate, lots of people will bid, and you end up with a price above the Zillow estimate, right? So there's a lot of head game going on in this. The markets change rather dramatically. Okay, so here's something that vaguely looks like code here, and lots of comments. And we're going to sort of like play games with these coordinates. And we're going to use this little module called the Vicente module. Here's somewhere here, in here somehow or other. So this is all just sort of hacked together code, admittedly, because I just wanted to get to a solution long before it's going to turn into a product, if it ever does. So we're looking for overlaps. And you can just see I'm doing all sorts of random things there. And then we're actually going to bring up a Jupyter notebook and see if we can get this to play a little bit. Okay, so geopy is a really great module, and it has ways of converting locations into street addresses to longitude and latitudes, right? Because how do I know that 47 St. Catherine is close to 1400 Barry, say? I have to get the geographic coordinates, right? And then come up with a metric between those. So there's a little bit of math magic that goes on, but right here we get this distance. Sorry, it's in miles here, but you can do it in kilometers just as easily. And now you may have some problems because you're using a service, right? So you may time out, or you may have too many requests, or you just may not be able to get there, okay? Or you might put in a coordinate into the system. It'll let you just put in street addresses, which is great. And either here or on the next slide or somewhere or other, I don't know if I can find it here, but it doesn't really matter. I'll just tell you. If I put in my street address in California, but just the name of the street, it'll very happily give me an address in Australia. And then, the coordinates in Australia. So you have all sorts of hidden cases. Your code will work 99% of the time, then all of a sudden you get these weird outliers because of the way the service is operating. Oops, sorry about that. Fuzz. So here you see what the data tends to look like: list price, sales price, selling agent, square foot, listing agent. Now in real estate transactions, there can either be, there's always a buyer and a seller. That might be all. You might also have a listing agent who represents the seller and a selling agent who represents the buyer. That's the terminology. And each of those agents then is part of a brokerage, and that brokerage is part of an MLS, a multiple listing service, which are owned regionally at least throughout the US. Okay, so then we kind of look at, there's just a little more about the vicinity stuff here, but we're going to actually look at these prices. And I'm showing you a Jupyter notebook. If you haven't used Jupyter, do so, it's very cool. This is using pandas as well to set up the data frame. And you see I have all this really very cool math I can put in here, where I'm just filtering on, is the price bigger than $750 and less than 850,000. So the table is kind of huge there. Okay, let's see what else we got here before we jump in. Okay, so this is what I wanted to produce. And so I wanted to put dots on a map. And there are more dots on a bigger map. And so I'm harvesting these. And before I go too much further, I did want to bring this up here from Zillow's rules of the competition. So the Zillow data doesn't have this stuff in it. That's why I'm interested in it. In the Zillow competition, which they've closed the first round and now they're on to the second round, they say you can go ahead and include extra data as long as it's not information that is typically entered into a multiple listing service. If they say you can't use it, of course, I'm going to be curious about what information you can get out of it, and that's part of what drove my looking at this data. We'll take a look at the Zillow data very quickly. Yes, very quickly. Okay, so here we are. We're just a couple samples here. And here are all the properties sold by a given agent during a time period in a geographic area. And so drawing the box, right? And coming up with putative farms and drawing a radius around the diameter there, and then trying to come up with a convex hull, right? The nice SciPy package for convex hulls. Okay, and here we go here. All right, so there's the convex hull. Sort of like started grabbing stuff outside the area, such as it is. And for a given agent, we're looking at, okay, is this person above or below? Are these properties in a farm or not in a farm? And the conclusions, right, is that you can run this on lots and lots of data and make yourself smart, maybe rich. Okay, so there's my realtor wife, Zelda, sort of inspiration for much of this. And now let's actually bring up some code here. Okay, let's try this one first. Okay, so here's Zillow, and I'm just going to use a Jupyter notebook here. Okay, lots of stuff happening there. All right, so pandas, Wes McKinney, right, buy the book, use it. Okay, so the asterisk means that it's thinking. Now it's reading in the data set. And these are the actual Zillow data sets, and you can see it's kind of big, comma-separated values. They give it to you as a zip. If they give you a training set, etc. Okay. And we're just going to grind through this so they give you transaction dates. And so here are the different quarters. They're asking you to come up with prices. Doing some more reading. Ooh, it's going to take a bit. So that's why big data is called big, because it takes big time, big space. And this is already downloaded, so it shouldn't take that long. Anyway, we're going to let that do whatever it needs to do. And I'm going to bring up another package here. And this is just really cool. I picked this up at another conference. This is somebody else's talk. Okay, but I mention it because it is so cool. Here we go, back here. All right, so it downloaded this, and let's go over to the other talk now. And this is geospatial, and there is a notebook that you can give. Let's see, I'm not a native New Yorker. This is very cool. It uses all this stuff, and it's a great tutorial. So I'm just going to really scream through this so you can see the sorts of things that it can do without executing it, because don't really have time to do that. Okay, but you can get all sorts of figures plotted in here. Okay, so let's go to the next step here. And using a low XLS, and there we go. This is what our dictionary looks like. And these are the different parameters that are in the Zillow data. So very similar to the information that you would have in an MLS listing: square feet, location, number of bathrooms. You usually don't include things like crime rate in a MLS listing or anything else. So here's more of this really cool site, and I should really post the author's name here. Sorry, let's just find it here. I'm going to where is it? There we go. So the author, oops. I'll post it on the slides. Okay, I thought I had it there handy. Okay, so I killed that notebook. So I think we can dispense with this one and this one. And now let's bring up another one here. This is mine. And we're just going to go ahead and try to run this. Find the farm. Okay, so how many of you are still using Python 2 at all? Oh, a few brave souls admit it. Okay, so if you're ever doing any porting from Python 2 to Python 3, right, there are tools available, but it's always a little bit of a headache. So I started off with just using doing stuff in flat .py files, .py files, and I thought, oh, I should put this into a notebook. So we'll sort of like get this going here, and there's sort of all sorts of stuff that happens. And the one thing I wanted to do was to be able to choose a realtor from a pull-down list using a widget, JavaScript widget, right? And what I ran into is I can't do that in Python 2. Got to do that in Python 3. So I created a Python 3 hack where I bring up another Python window here. Let's see here. Yeah, let's go into Python 3. And let me open up this window here. Okay, so it is possible to have both a Python 2 and a Python 3 kernel inside of your Jupyter notebook. If you only have one, it'll default to it. Oops. And it's really hard to force a Python 2 notebook to use a Python 3 shell. Anyway, I couldn't figure it out. Why am I not happy here? Here we go, in the wrong directory. Here we go. Okay, so here we are in Python 3. And I think we're in Python 3. Yes, Python 3. And, oh, I don't care about that, or this, or this. I'm just going to go down here, and I'm going to import pickle, where I have my list of realtors from my Python 2 code. I'm going to import widgets here. Come down here, right? So you can jump around these cells. Thank you. And voila, here we go. Here's what I wanted to do in Python 2, but I couldn't do it. And this is the list of the 3,000 realtors. So 3,000 realtors, 4,000 transactions. That tells you that a lot of realtors are not doing much activity, at least in that geographic neighborhood, because it is a sparse event. If a realtor handles a dozen transactions a year, they make a good living. And so we're going to just pick a realtor here. Let's see, I'm trying to pick one which I know works. Pearson, here we go. So these widgets in the widgets library, very nice. Takes a little bit of tweaking to get used to it. Here we go. So we'll pick. So we'll first try to pass this as a environmental variable. That's not going to work because the environmental variable only exists within the child of the process that's in this notebook, and it won't talk to this environment at all. But we tried that anyway. And so now we're going to just create it into a file and then read the file, right? A real mega hack, right? Because you hate to create temporary files to pass information back and forth. But it's a start. Okay, and there it is. We see the realtor, and there's, okay, so now we'll come back over here to this one here, and we'll kill this one off, and we'll bring up the modified version that kind of uses the hack, and we'll see if I can do that in the 7 minutes I have remaining. Yes, okay. So let's just see, where are we? Over here. Jupyter seems to be hard to kill, sadly. To kill nicely at any rate. There we go. It's dead. Okay, that one I don't care about anymore. Also, the Jupyter Notebook does some weird things with ports. And so if you leave one open forever, it can sort of start clogging up all sorts of things. All right, so let's come over here. We'll start up this notebook, and we'll just zoom through it again. And I'm going to cheat a little bit because I've already picked the realtor. But in reality, I would have 2 keyboards going and go back and forth until I figure out how to just sort of cheat from within the notebook by spawning a Python 3 shell from within my Python 2 project to bring in the variable. But it can be done, right? All these things can be done. The other thing you have to worry about with Jupyter Notebooks when you're doing anything with widgets is you have to be able to tell that you're interactive or not. So there's some hacks to do that as well. Okay, so here's the piece that didn't work locally. So we're just going to go ahead and jump down here. Didn't work getting it from the environment. That was a shame. But it does work. Oops. No, it didn't work. Oh, that's because, I couldn't change. Okay, in Python 2, it created this thing, but the widget didn't do anything. So I said, well, let me just go ahead and change the value of the widget, but that won't work because 5 minutes, thank you. Because of the way the widget has its dictionary set up. All right, so this is what we're going to do. We're going to come down here, and we're just going to keep challenging ourselves here. And instead, we will just, I'll show you what we end up doing. Okay, so here's where we actually start doing some of the code. Excuse me. Okay, so right here. Here I'm going to grab the value. I'm going to skip that whole widget thing and just grab the value from using a Python magic, using the exclamation mark to go out to the shell to have it read the file realtor that I created on the other side when I chose that realtor from the list. And then I'm just going to stick that in, and we'll just sort of keep on grinding here. Okay, so the problem here was that I got a list. I didn't get the string. It put the string into a list. So we had to fix that. So now we're going to try to plot our results. And in the interest of time, I'm just going to go ahead and show you the two files. And if this had worked as well as it did in my hotel room, we would have seen this pop up. And we see here are her number, the two farms that this person has, the two neighborhoods. And if you look closely, you may be able to figure out more. So the idea behind this, 1 minute left for questions. Any questions? Okay, so the idea behind this is that there's more data out there than is normally being used, and that the effects of personalities do make a difference often. In this 5% that Zillow's trying to nail, in large part is due to the negotiation skills, I feel, of the realtor and the circumstances. Right, you may have multiple offers coming in, but one will be a cash offer, and the other one will have a mortgage contingency, a contingency on the sale of another property, or an inspection contingency. Even though the price is higher by, say, $5,000 or $10,000, the seller may just want to grab the cash offer instead, right? Or you may have someone needing to move, so there's a relocation. The person has a price guaranteed by the realtor. They don't really care. They just want to sell it. And so we're gathering all this data. If you're interested in more of this, you can contact me at, oops. Oh, maybe you can't. That's kind of a shame. All right, you can't contact me. Life is hard. Okay. Anyway, catch me in the hallway. And, oh, I think I may have lost my connectivity. All right, thank you, everyone. I'm happy to chat.